Keen Academy, Unit 1. The question we will solve today is page 73, number 3, application of Newton's second law in 2D. Use the grasp method. Givens, required, analysis, solution, and phrase. Here are the values given from the question. The mass is 1.5 times 10 to the 2 kilograms. The gravity is 1.47 times 10 to the 3 newtons downwards, and the tension is 1.8 times 10 to the 3 newtons to each side. The value that we are required to solve for is the acceleration of the beam. Now, how will we do this? First, draw a free body diagram, then define net force and solve for acceleration. Here is the free body diagram. Those are the two tension forces from the ropes, and that is the force of gravity. The angle between these tension forces is 30 degrees. Looking at our free body diagram, we can see that the net force is the sum of the two vertical components of the tension minus the force of gravity. This notation is for the vertical component of the force of tension. To find the vertical component, we draw a vector diagram. And using trigonometry, we see that the vertical component is equal to force of tension times the cosine of 30. Plugging in the value of the tension in rope 1 will give us this equation, which we will keep as is to avoid rounding errors. Since the magnitude of the tensions are equal, so are their vertical components. And as a result, we can sub this and rearrange our original equation to the net force is equal to 2 times the vertical component minus the force of gravity. Next, we plug in our values into our equations. And following through with the math, we get 1,647.69 newtons upwards. Rearranging the FNet formula for acceleration, we again plug in the numbers and round off to 11 meters per second squared upward. Our final answer in a sentence form is the acceleration of the beam is 11 meters per second squared up.
Created using Powtoon.